All right, so you're prepping for the LPIC-1 exam, and you've learned how to partition a disk. That's a great start, but it's only half the job. A raw partition is basically useless until you give it some structure. In this session, we're going to break down the tools and concepts you need to create and really understand Linux file systems. Let's get right into it. So first up, we're going to talk about why we even need a file system in the first place. Then we'll get our hands dirty on the command line with MKFS, which is your main tool for this. After that, we'll look at the big players in the Linux world, that's ext4 and XFS, and then we'll cover the file systems you need for sharing files with other operating systems like VFAT and exFAT. And to wrap it all up, we'll do a quick review to make sure all this stuff sticks for your exam. Okay, so you've used fdisk or parted and you've successfully created a partition. Awesome! But right now, what you have is just empty space. Your operating system has no idea how to store files there, how to find them, or how to organize anything. All you've really done is build a logical fence on your hard drive. And this, right here, lays out the whole process perfectly. The physical disk, that's the container. The partition is that fence we just talked about, walling off a section of the container. The file system, and this is the key step we're talking about today, is the organizational map that you lay down inside that fence. It creates the rules, the structure for directories and files, and finally, the mount point is like the gate you connect to your main directory tree so you can actually get in and use that space. All right, quick pop quiz. Based on what we just went over, what do we call that specific point in the directory tree where we attach the file system to make it accessible? Did you get it? It's the mount point. Exactly. So we get the why. Now let's dig into the how. How do we actually create these organizational maps on our partitions? Well, in Linux, we have a fantastic command line tool for the job called MKFS. And I love this analogy, calling MKFS the Swiss Army knife of file system creation. It's a perfect description because MKFS isn't really one single program. It's more of a clever front end that, behind the scenes, calls on other, more specific tools to do the actual work. It lets you create pretty much any kind of file system you'll ever need. Now, you'll see two main ways to use this command. You can either call the specific tool by name, like mkfs.ext4, or you can use the generic mkfs command and tell it the type you want with the T option. Here's a key takeaway for the LPIC-1 exam. Both of these commands do the exact same thing. They'll give you the exact same result. Okay, I need you to listen really closely here. This is probably the most important warning in this entire session. Using MKFS to format a partition is a destructive act. It will completely and utterly wipe out any data that's already on there. You have to always, and I mean always, double-check that you're pointing at the correct device. A typo like SDA1 when you meant SDB1 can ruin your day, or worse, your entire system. Be careful. All right, let's see if that's stuck. If you're using that generic MKFS command, which option do you use to tell it what kind of file system you want to create? Yep, you got it. It's the T option. All right, we've got the tool, MKFS. Now let's talk about what we can build with it. We're going to start with the file systems that were made by Linux for Linux. These are the powerful workhorses you'll be using for your main system partitions, primarily the ext family and XFS. But before we compare them, we have to talk about a concept that's huge for the exam, journaling. The best way to think of it is like a to-do list. Before the system actually writes your data, it jots down a quick note in a special log, the journal, saying, hey, I'm about to do this. If the power suddenly goes out or your system crashes, when it reboots, it can just look at that journal to see what it was in the middle of doing and fix any unfinished business. It's an absolutely critical feature for preventing data corruption. Now, the original Linux file system family is ext, which stands for Extended File System. It started with ext2, which was solid, but it didn't have journaling. Then came ext3, which was basically ext2 with journaling added on top. And that brings us to today in ext4, which is the default for a ton of Linux distributions. It's fast, it's reliable, and it can handle gigantic files and file systems. In creating an X4 file system, the modern standard is as simple as this. You just use the command mkfs.ext4 and point it at your target partition. It's clean, it's effective, and it gives you that super reliable, journaled file system we were just talking about. So, besides XF4, the other big name in the native Linux world is XFS. This is another really powerful journaled file system. Its speciality is handling large files and high bandwidth situations incredibly well, which is why it's a huge favorite for servers. In fact, it's so good at it that it became the default file system for big server distros like Red Hat Enterprise Linux 7. And you guessed it, making an XFS file system is just as easy. The command is mkfs.xfs, followed by the partition you want to format. Simple as that. Okay, quick question for you. Between XF4 and XFS, which one is the go-to default for server-focused systems like Red Hat Enterprise Linux 7? That's right, it's XFS, all thanks to its incredible performance with large-scale data. Okay, so these native Linux file systems are awesome for our Linux machines. But what happens when you need to share a USB drive or an SD card with someone who uses Windows or a Mac? Well, that's when you call in the compatibility crew. First up, we have VFAT, which you probably know better as FAT32. This is the old timer. Its biggest advantage is that pretty much any device on the planet can read it. But here's the catch, and this is a big one for the exam. You cannot have a single file on it that's bigger than 4 gigabytes. That makes it really only useful for smaller flash drives or older gadgets these days. So to fix that 4 gigabyte problem, we got exFAT. It completely smashes that file size limit. We're talking files up to 16 exabytes, which is huge. This makes exFAT the modern choice for sharing data across platforms, especially on large external drives and modern SD cards. In fact, it's the standard for any SDXC card over 32 gigs. All right, let's put this into a real-world scenario, the kind you might see on the exam. You've got a 64-gigabyte SD card, and you need to share some really big video files with people using both Windows and Mac OS. What file system are you going to use? With a big card and big files needing cross-platform support, exFAT is absolutely the way to go. Whew! Okay, that was a lot of information. So let's boil all this down to the key things you absolutely need to remember for your LPIC-1 exam. Seriously, this table right here, this is exam gold. Screenshot this, write it down, whatever you need to do. It perfectly sums it up. For your native Linux systems, you've got the journaled ext4 and XFS. ext4 is your all-around default, and XFS is for your high-performance servers. For sharing files, you've got the non-journaled VFAT for older, small media, and exFAT for modern, large, cross-platform storage. And finally, let's talk about the traps people fall into, the mistakes you are going to avoid. Number 1, the big one, formatting the wrong device. I can't say it enough, just be careful. Number 2, don't mix up what a partition is versus what a file system is. Remember, one's the container, the other's the map inside. And last but not least, don't forget the final step. Running MKFS is great, but you can't actually use the file system until you mount it. So I'll leave you with this final thought to chew on. Now that you know the options, for your own personal home partition, where all your important files live, which one would you choose? Would you stick with the reliable, all-around ext4, or would you go for the high-performance XFS? On the exam and in the real world, understanding why you make a choice is just as critical as knowing what to choose. Keep digging!